Okay, so I'm going to do this in two parts. I'm going to do a first part where I'm just going to kind of go through this concept of making fact-based decisions, and then I want to try to show you how much of behind the scenes of OWASP and the stuff that's happening there. And I think for that part, it's probably better if it's more interactive, ask questions as you go along, because I want to make sure you guys kind of understand the technicalities part of it. So I kind of arrive at this by basically keep graphing it, right? So I feel that I've been graphing since I was, quite a young age, because for me it's all about nodes and edges, it's all about connections, it's about, A to B, this thing connects to that thing. Even when I was doing source code, I eventually realized I was actually doing graphs, I was actually doing maps, I was actually connecting dots. So, so this is kind of what I talk about is a story about how do you do security at scale? How do you actually connect the dots and giving you a seat at the table, which I think is kind of a conversation. And to be honest, I think there's a very part here that if you don't have a seat at the table, it's because you don't deserve to be there, right? I think you have to be very brutal, right? Because if you're not invited to the meetings, it probably means because the people on the other side doesn't think that you got enough value, right? And the problem in security, we usually don't, because we're the ones who say no, we're the ones who don't bring solutions, we don't give visibility. So I think we need to change that. And part of it is because we don't work in facts, right? So if you look at most of the kind of security industry, and even our security knowledge, right, it's, a lot of it is magic, right? A lot of it is kind of hints, a lot of it is kind of fluffy data, right? It's very hard that you can say, I need to make this decision, here are the facts, here's the situation, here's the understanding, here are the risks, here's the side effects, now make a decision. Usually that's easy, right? That's very easy to make those decisions because it's very logical, right? You could say, well, I get it. I got A, B, and C. Well, A doesn't look good. B is maybe too much. Let's go for, let's go for something there. Right. So it's about connecting, right? Data source and knowledge. So some of you might look at that and say, whoa, that's very complex. Others might look at that and say, wow, that's great, and that's very simple, right? Because the reality is that's a graphical representation of all our Jira tickets. And by the way, when I talk about Jira, which is ironic because I still think Jira doesn't get it, that they actually have a graph database. If anybody actually knows anybody at Jira, I'm still trying to talk to somebody there to actually connect, right? But actually, let me just define a graph because I think that's better, right? So for me, it's nodes and edges, and the node has to be something very strong, right? So a node is a person, a node is an issue, a node is a risk, a vulnerability, an incident, an event, everything that you can think of, we will make a node out of it, right? And every one of those has to be version control. It has to have a title, a description, it has to be tracked, it has to be audited, it has to have a description, it has to ideally maybe have a thread conversation about it, it has to have labels, maybe a time to a person, maybe add a timestamp, it better put a workflow on it, so you're gonna have, so your node actually travels kind of through a set of states. Well, I just described a ticketing system, right? If you look at ticketing systems from Jira, ServiceNow, all the others, it's kind of the same thing. So I use kind of graphs in that way, right? So I don't need millions of nodes, I don't need throughputs of milliseconds, I need a graph that holds thousands of nodes. And Jira happens to be quite good at that. So we still need a graph database. In fact, I start working on a serverless graph database. Anybody wants to kind of join the party? The first part of the code is up there, so have a go. So in a way, it's about transforming spreadsheets. So there's other people who have work here, be part of my team, so I think they know how much I kind of don't like spreadsheets, right? And to be honest, more and more I realize the whole freaking world runs on spreadsheets, which is insane, right? Although there was a really interesting thing where I think it was Greece that actually got hit pretty badly because there was a problem with one of the spreadsheets, right? It just shows you how insane it is. You're making spectacular decisions about the future of a country. Like, I've seen decisions made about people that are sitting on top of spreadsheets. And my confidence that the data of those spreadsheets was actually correct is insane. In fact, I think if you want to blow a company, just hack the spreadsheets, right? Because that's the end step for reality, right? Because there's no cross-checks, right? There's no kind of validation of what the hell's going on, right? Because it's on a spreadsheet, right? And spreadsheets, again, very, very weak version control, very weak understanding. Everything in there is a spreadsheet, so is a node, right? So every cell in a spreadsheet is a node. So every cell, just to put it in context, right? A spreadsheet will be okay if every cell was tracked in version control. If every cell, you could think of it individually, had workflows, had name-value pairs, had attributes, etc., then you'd be good. If not, this is just a very kind of dumb graph because it's just nodes and edges and then you can manipulate the stuff. So what you actually see there is actually an output from Jira to spreadsheets. Sometimes you can't fight all the way, so I kept arguing against spreadsheets, and I realized actually spreadsheets are not a bad way to do stuff. So we actually, for a while, had a way where we took the data from Jira, we put it on a spreadsheet, and then we bring it back to Jira, right? But then when we got to Jupyter Notebooks, we realized that was a way better way of doing that. So it's about doing data science visualization to create feedback loops. So you can see here is a Jupyter notebook, and that just shows, like, for example, the same graph, a variation of the graph actually running on it. Like, who have used the Jupyter notebook here before? All right, for the ones who haven't, like, you have to, right? This is the trick. This is how data science is being done in a lot of ways. You really have to try to get your heads around it, because everybody here should code, right? So in my view, if you don't code, you can't automate your world. But it's not code PhD or code kind of, that's sort of like a PhD level in math or super complicated stuff, right? You need to code to automate your workflows, right? What you find is that when you use a technology, when you use the internet, right? The internet 15 years ago was this weird thing, right? People didn't understand it. Now for you it's natural, but coding, especially when you automate your knowledge, is the same thing, right? And that's very important. The other key part here is the feedback loops. So what I found is that the key problem with all this stuff is creating feedback loops in your workflow. And that's the biggest gap. The biggest gap I see is, it's very easy to over-engineer. It's very easy to go down on tangents without creating feedback loops. So what you want is to create workflows where you create super feedback loops immediately. That's why I like the idea that you give yourself the problem that you want to solve. Because in a way, that's the shortest feedback loop you can get. Because you try something, doesn't work, or what I want to do doesn't work, then you keep trying it. My advantage is because I can code at a lot of levels. I can have a problem at top level, then go, well, it should be easy, well, I don't have that, well, I need this, I go here, then I solve it at this bottom, and then I go up until it gets easy, right? But it should be easy at the top. It should be very easy to create this kind of stuff. So it's about DevOps, as you see in practice, secure operations, secure data, secure decisions. Most of that stuff is made with very little data. If you want a simple example, right? When you push, for example, data, let's say on serverless, DevOps, right? This is really cool. Secure as code, you push code, you do CloudFormation stuff, right? Where's your test for the CloudFormation, right? But it's not a test for the CloudFormation itself, it's what happened with the CloudFormation. When the CloudFormation, for example, adds a setting, you should have a test that tells you that, right? So now, if you have that, you start to have data. You start to have an understanding that you can take that and you should be able to connect that all the way to a policy. Right? So if you have a policy that says we will not have open, or this particular set of firewalls, or this particular set of settings, or this particular set of configurations, you need to connect that firewall all the way down to the actual code changes that are doing that and the test that does that. If you don't do that, then it's all kind of air in the middle, right? And you see an example in a bit. So it's all about risk dashboard. So what's interesting about this is basically a risk dashboard that you take the kind of the end of our graph at the actual top level, and then you create these kind of workflows. And by the way, like, when I present a lot of this stuff, right, and then for the people that work with me, like, this is still work in progress, right? Like, I'm telling you a direction, how I think, how I should go. The solution around development, again, if you can help with the development of the security part, would be great, right? So this is the stack, right? So what we do is we take the graph database, which is Jira, right, in this case. We put it into Elasticsearch because in a way, Jira, or this, ironically, Jira is a relational database. It actually runs on top of SQL, right? The problem with relational databases is they're really bad at relations, right? So, because they're good at SQL, but SQL gets very insane once you group stuff around. So performance-wise, the relational databases are really bad. A graph database is much better because you actually get a much cleaner query because you just query one node at a time. So basically what you want is you want to take your data and you want to pump it into Elasticsearch. So I still think that a great service is take the spreadsheets and put that in Elasticsearch, right? That makes the spreadsheets 10 times more useful, right? So what we do is we take all the data from Jira, we pump it to Elasticsearch, and then we use a serverless environment, in this case Lambda, to consume it in both Slack and Jupyter. Now the serverless environment, in a way, was my magic sauce. In the past, and if you follow my history of development, I've built lots of crazy stuff, lots of great features, lots of stuff that when I show everybody was like, wow, that's really cool. The problem is how to make it scale, how to actually get somebody else to use it, and that was always my problem. And my problem was, this is cool, but it works on my laptop, or works on that server, or works here. But I could never kind of try to package it. In fact, in the O2 platform, I got to the point where I would even create mini tools programmatically from .NET to just get an executable, right? It was really cool, but the packaging was still very hard, right? The serverless is a very interesting thing. And the serverless is not Lambda, right? Lambda actually has tons of gaps, right? But the serverless concept, which is the idea that you take a chunk of code and you package everything you need to run that bit of code. In fact, you take a bunch of actions, or what you do, and you have the code required to run those actions, and you package it in an environment where it just runs, it just starts. You don't care when it starts, you don't care when it ends, you just have this natural flow of that bit there. And I would even argue that the way I use Jupyter notebooks is serverless, right? Which is, we're going to get that in a second, right? But that is fundamental. And what I've found with serverless environments is that you get a cleanness of architecture that is very hard to do. So what's interesting that we spend the last 10 years of people complaining about microservices and you can't control it and it's a big bad and all these philosophical discussions of microservices, right? Meanwhile, serverless comes along and it's actually a microservice, right? It's even that on steroids, which is the problem we have because you can't even visualize one model. The service workflows are just insane. But the good news is they're cleaner, they're kind of smaller, but they also create all sorts of interesting things. Just one comment here, right? I think one of my biggest competitive advantages as a professional is I'm very technical, right? And I would argue, as I move into management, I have a competitive advantage that I know how things work. So I can make a lot of decisions, I can make a lot of assertions because I actually understand the tech. So if I can give one advice, wait until you go to management, right? Senior management until you get senior, because the nice thing of being senior management, you can actually control your time. Well, you know, if you're not careful, you don't, but if you're careful, you can social engineer your way into working very strategically and then working very technical. So in fact, I've been in situations where I'm actually, and I tell my team, in this project, I'm working for you, which is really cool, right? Because basically I'm working for a person who actually managed by some other person that I actually manage. Right? But I would actually argue that strategically, it's really interesting because it's the best way for you to get a feel for what the hell's going on, right? Especially as your team grows. So I would argue that I'm a very valuable resource, I'm a technical resource available, and that's how I keep my skills sharp. But I understand serverless today in a way that I would never understand, right, if I hadn't coded. And it's interesting because I remember seeing the serverless kind of wave flying around, and I kind of got it. I kind of got why it was important. I never really understood it to the point where, you know, a lot of the concepts for me are very native, right? So here's the OSBost in action, right? Where basically what we created in this was a feedback loop. So one of the things that's very important is you need to have a CLI, right? Or you actually have a REPL, right? Which is read, execute, loop, and print. So you need to have a way that you can interact with the data that you consume, right? You need to be able to ask questions, get answers, and you need to be able to augment it. Right? So my workflow on this was I have a problem, I need to be able to execute it, I will go in, I'll create a method, and I get a feedback loop, right? And that was also a way for me to scale to the team. Because once I got something that worked for me, I go to the team and say, hey, here's the commands, here's how you run it, you know, there you go. And that was already a massive success because suddenly they can consume it. And this is where the bits connect together. Because it's no good to have a great workflow here if your team can consume it, if the business can consume it. So the business went to Slack all the way, which is great. So we're using Slack as a CLI. We're using Slack as a command line interface. But it's not this kind of dumb bots that most Slack are. It's actually a feedback loop. You make changes, you get feedback, you interact with it, interact with the data, which is very powerful. So you can see here, right, you know, have all sorts of stuff on it. So what you get is this sort of what we call read, you know, evaluate, print loop. So you get this flow where I can go and say, hey, can you take this graph, can you expand it for this ID, and can you go on a particular path, right? And then what you get is a sequence, or in this case, of risks. So by the way, every yellow box here is a Jira ticket, right? And it'll go even bigger, right? So what you have, for example, is a project. In fact, you know, Jam is there, she was running that project, right? And that project reduced the risk, which we call in this case our R2, so R3, sorry, who creates what we call the R2, trust to brand, who then creates the risk to brand, right? So what's powerful about this is, and here's a first example of the fact base. So I can say, hey, we have a potential for our risk to brand. So there's a higher risk of our risk to brand. And somebody says, why is that? Well, because we might have problems with the trust in our brand. And why is that? Because, you know, we might lose the trust in the brands. And why? Because, right, we're not out there, for example, speaking. We're not out there showing that the security team is actually active. We have a valid thing. Now, this is very thin, but you can see there's way, way more examples of that. So the interesting part here is to say, when there's a vulnerability or a fact, right, we play around with that, is you should ask the question, why does it matter, right? So, and that's very important, right? That's how you get to the facts. And this is, there's no magic sauce here. What you need to do is you need to reverse engineer your organization, right? So you need to reverse engineer your organization to say, what is the language that they care about? So you need to say, hey, I have this, so why does this matter to her, right? And you might go, okay, because of this. But why does it matter? and then you go to the next one. And why does it matter? You go to the next one. Every time you go up a level, you hit different stakeholders, right? And that's how you scale. And then the power is that you can do this for everybody. So it's cheaper once you get this working to reverse engineer the other side to say, what does that person care about? And then connect that to your data, then try to convince them to your. So I remember when I went to the team and says, I want 50 PowerPoint decks or 50 slides, I almost have immunity. Everybody was not very happy with, right? But, actually my head was like, actually I need 500, right? So it's like I go, let's go with the 50 for now. But the reason where, if you go back, 6 months later, we were creating a lot of those because we were creating Jupyter notebooks. We were programmatically creating slides from our data, which basically is customized presentations, right? And that's how you scale. Right, so here's an example. Where's George? There you go. Here's an example of George developed this with a bot, actually on top of a Jupyter notebook, right? Which is the power, right? The power is that when we actually were coding Jupyter notebook, he had actually APIs, so he actually did it on top of it, right? So the workflow here is that this particular case, we worried about a login to a particular mailbox outside working hours. So it's a good example, again, of making good decisions, of fact-based decisions. The business says, I need that mailbox to be shared. We go, that's a bit dangerous because now there's people log with accounts. We reach a compromise to say, okay, as long as people only log in from the office, we start to get at least, we reduce the risk, right? Because at least we know that only people there. Now the question is, what happens when somebody logs in outside the office? So what we then put is a workflow to give us an alert, but there's lots of very interesting parts here because we're actually using, in this case, the graph database as a state engine. So what you have here is the first thing is you have alert being created, being picked up by a service analysis that say, hey, a shared mailbox has logged in out of working hours, right? So there's a ticket that got created and said, hey, this happens. And then what happens is the user get the bit at the top, right? So we go to the user and say, hey, or in this case, the assigned channel that happens to this is, hey, did you log in to this mailbox outside this time? Right? The person goes, yes, that's me, we acknowledge it, we update, and then we close the ticket. So the person said, no, it wasn't me, we will start an incident. So what's very powerful about this, yep?
So in case of internal threat, so sorry, you did something, yes, you did.
Yeah.
Oh, so cool, it's an internal threat.
Sure, but what's interesting about it, right, is that, depends on the scenario, right, we could be doing other things. Right?
You investigate somebody, you tell them that you are investigating on them.
Yes, and this is the thing, right? I always think that the way you handle malicious players in your network, right, is not to depend on one signal, right? Is not to have just one thing that happens that you detect out. So in your case, yes, that's a potential blind spot, right? But what's interesting about this is this actually went to a shared channel, right? So, in this case, if the person says, yes, it's me, other people are actually watching. Right? So, and you have to realize, a lot of security is about convention, right? A lot of security is, for example, if somebody knows us to be doing this, they actually probably won't do it. In fact, we have now users coming to us and say, hey, by the way, I'm going to do that this weekend, right? We go, no, that's fine, just click the button, it's so cool, right? But it's, you have to remember that, what will that person do next, right? So the interesting thing about these workflows is that this cleans up your list, right? So what this does actually, this automation cleans up your events that you're getting so you can turn up the volume for other situations. For example, what will happen after that person logs in, right? Because if we were, in that case, if we were that worried about insider threat, for example, we would have a lot more protections about what's going on, and we probably wouldn't tell the user. So you can then start to look at how many emails got seen, what kind of files got worked, what kind of attachments got there, so you can think about that. And remember that the insider threat plays a different game, right? With insider threats, normal security doesn't apply, right? Because they will play the game. So you need to find other things that will do that a normal employee would never do. And that's, for me, how you play that game. Cool, all right, so what now happens is you start to create a Jira schema that represents the business, right? So now every one of those boxes is an issue type, right? So every one of those boxes, we have a business unit who will fund a function. Does this thing have a...
Yeah, it does.
Oh, this, yeah. Okay, so you got a business unit, funds a function, who actually funds a team, for example, who's going to deliver some capabilities, who have some processes, there's a policy, which I'll show in a second, and actually there's some skills, mapped to some roles, and then there's a person assigned. So now we get to a different type of graph. So now that person has access to a particular asset. So this is our asset, right? And now that asset is connected to a particular type of mailbox, right? And that mailbox has a bunch of facts, right? And so facts was a very interesting thing. So facts was something that we started to introduce because in the beginning I would call all these vulnerabilities, but then that became very loaded. So the interesting thing about facts is you can state reality. So you can say, hey, this happens. I don't do this. That mailbox is accessed by a number of people. That mailbox, we never had an incident with that mailbox, right? That's a fact, right? That fact will affect, for example, your profile. We have very high trusted people access that mailbox. Or we don't have highly trusted people in that box. There's a pile of interns accessing that mailbox, right? So, but all those are facts. So then what you do is you extract the vulnerability. So these facts might create a vulnerability. In this case, that it's possible for a malicious actor to access the mailbox. And what that does is that creates a risk. And then you go into the 5 whys to follow all the way the food chain. So this is how, when you accept a particular risk, you should have this whole flow. Because if you don't have this whole flow, you don't understand the game you're playing. So for example, if you don't have this whole flow, you can't know who are the stakeholders that you need to talk to, right? And actually, who's funding that thing? And who's fundamentally taking responsibility, which is going to come from here. So that box over there, right, which is kind of like probably 7 or 8 or 9 degrees away from your graph, actually contains a person paying for all of this, right? It contains a person that has to make accountable for making that decision. And if you have that, you're now making fact-based risk decisions. So here's more stuff, right? Here's other variations. You have business structures. You have IT systems. So IT systems is a good example. So an IT system is connected to another IT system. It's connected to an account. There you go. It's connected to a device, an application, API, etc. Right? This is the reality, right? If you don't have this level of granularity, you don't connect the dots. Like the biggest problem we always have is actually who the hell owns this? Who's going to fix it? What's the dependencies? What's the side effects? The insecurity, right? We are a gigantic factory of change, right? We go to the business and ask them to change all the time. The problem is change is one of the hardest things you can do in business because change has side effects. And every time you have a side effects, you build an attrition. People in that area don't like change. Because last time you changed for a problem this big and they had to deal with a problem that big. So you put other stuff in place. Where we go along and say, hey, change this, change that, change this, change that, because that's what we want to do because we want to harden it. So the more we allow change to be understood and the side effects to be understood, the better we are. And actually goes to a point I like to make is that security, we are uniquely positioned in a business to give visibility to the business. So we should be playing the business intelligence game. We should have a seat at the table, actually not even for security. We should have a seat at the table because we understand what the hell is happening in the business. Because we can see it. We see it in our logs, we see it in our analysis, we see it in our incident response team, we see it in the data that we collect, we see on the side effects, on the incidents that we handle. We should be able to tell that. We should be able to tell if the marketing campaign was effective, right? Because if that marketing campaign was effective, guess what just happened to your application? You're about to be doxed, right? By new users. So it's a good example, right? We can say which ones are ineffective. We can say what's going on with the application. We can tell the dev team that they just broke production, right? Because suddenly there's an impossible jump for our users that we may use to detect security vulnerabilities, but suddenly a bunch of users' shopping carts, for example, got dropped over here, right? Or the buying patterns of particular users got changed. Now that might be a good thing, or that might be a bug, or that might be an exploit. So we should be playing the visibility game, right, to the business. So this is something that, for me, I'm very passionate about because the thing, okay, very close in my heart of the kind of dislike for spreadsheets, right, is dislike for policies, right? Because the problem I have with policies, in addition that most of them are fairy tale, right, is the fact that they're not hyperlinked, right? So, you know, I remember freak out a whole bunch of risk people I was working on when I would look at a policy and say, oh, this is cool, but every line here is going to be a Jira ticket, right? But if every line in your policy is not a Jira ticket, how do you track it? How do you know that that line actually makes sense? How do you know that it's actually connected to the real world? How do you know which of those lines are today working, not working, are enforceable, are working for this team but not for that team, right? So what you have here is actually my home task for Revolut. right? So when I was applying for Revolut, right, they gave me a home task, which is, hey, here's a policy, and here's a VM. Can you basically apply the policy to the VM and check it out, right? And by the way, the home task I'm now giving to some of the people I'm interviewing is basically go to Jira and customize it. It's create a Wardley map and do a presentation about yourself, right? Because I don't like CVs, right? CVs are, it's basically, you can write anything on it, right? And I don't know if it was you or somebody else. So for me, again, if you want to apply, hey, by the way, we're recruiting. That's how I do it. So when I got this, I was like, there's no way I'm going to freaking deliver this as a presentation, right? So by the way, I added the logo at the top. Again, there's this thing called freelogos.com, right? So go there, type, 2 things, you get a nice little logo. Again, the professionalism matters, right? So what I did was I took the policy and I created on a temp Jira environment, created a bunch of Jira tickets, right? And then basically created the organization you have here, right? So, okay, so what you have here, right? Is basically that Ubuntu is the policy, right? This here is, oh, sorry. All right, there you go. All right, so that top level is the policy. This one here is the policy section. See, user authentication, data retention, there you go. User authentication, data retention, right? Each of these is what I call the policy kind of set, right? And each of these is actually the policy the rule, right? So now we have a rule that says for SSH access, certificate of authentication should be that there. So now I can track this back, right? Now I can do a policy analysis where I can say, hey, I'm going to review that policy against this build standard I have here. I'm going to say, actually, I have a fact, right? My fact is I can log in that VM without SSH. And I can log in without root. And this is where we always struggle. Because when we ask, why does that matter? Why does it matter that you can log in without root, right? Or with root or nothing, right? Then you can say, well, because brute force passwords are possible, right? And why does that matter? Because unauthorized is able to log into production, and actually, you're breaking access controls. But what you also have, you also connect these to the policy. So this vulnerability is also the one that is going to create the non-compliance with policy. Right?
And
so
is that a paragraph from PDF file, Dinis?
That one there.
Yeah, it's a paragraph with PDF, right?
That's the line, not the paragraph. That's the bullet point from the PDF, right? And that's, for me, now is, so you can see that policy creates this vulnerability is compliant to that. So you go to that policy, you can say who is not actually compliant, right? And then you see the facts. So when I say, hey, why do you say that brute force are possible? Because I have a fact, right? Because on that one, that didn't exist. So you can see that here, we're hyperlinking everything. We have evidence. So I can then say, hey, we have a lot of access control problems. Because on this particular case, I can track you back to the place where you actually have the access controls. Any questions?
How long does it take to decompose the PDF into a Jira ticket?
Well, first of all, it was faster for me to do this than to try to freaking write something that would explain why the thing was actually correct. In fact, what I did was also cool is that instead of actually providing instructions and screenshots for how to actually fix the thing, I actually created a Docker image that had a link to the policy that says this line on the Docker image is here because there's a policy that says it should have it. Right? So now again, you have the code to do that. What I should also have is a test. Right? That confirms. So I actually was writing tests. It was very interesting to prove these things, right? This is the problem, right? Our test environment sometimes is very weak, right? Because I was like, I want to prove this, right? And then how do you prove it? And then you need to find a way to run the Docker container, connect to the thing, or maybe run some commands in the Docker container. And it was really interesting because there was a time that I made a mistake, right? And I only picked it up when I run the test. And when I run the test, I was like, well, hold on, how do I test this? My test is failing or not working. I realized that the configuration that I'd done was actually not correct. Right? So, in fact, what I actually did, if you actually still online, I think, I actually connected that the fix or the fact. When I say it's actually possible to do this, I would actually link to the fix itself. So that became quite interesting. Oh yeah, so here you can see, right? So you can see the things I created: facts, policy, risk, security, vulnerabilities. And by the way, if you have never done this is not rocket science, right? The reason for me, I think this is the same way with code. If you today are not able to go to Jira.cloud, subscribe to it, and create this stuff, right? You're missing a trick, right? You don't have I would say you don't have enough minimal technical capabilities to be an effective member of a team, right? And the reason why is because this is how you should be capturing your data. And this is not rocket science, right? This is literally go there, a couple of clicks, make the change and go back, right? So you can take your time to learn, but I think it's very important that you're able to create things like this. So when we talk about facts and vulnerabilities, people don't freak out. And so we used to do this very effectively with incidents. So we had an incident, right? And this is kind of where it started. What we will do is we have every question on an incident to be a Jira ticket. Right? And because every question will be tracked, and there will be sometimes multiple epics and multiple stuff. But the reason you do that is because you're now able to track every single question directly. So we go to Confluence, and then we basically create a view that will show each of those, and we had a tool called Data Information that you can then see on Confluence. And what he meant that instead of having a massive freaking Slack channel, right, it was a salad of stuff, right, where people put stuff, people put questions, and some answer, then somebody comes a bit later and say, hey, what's going on, right, what's this, and then who's doing this, and blah, blah, blah. No, we would still do that, but we would capture all those questions in Jira. And every one of those will be a Jira ticket. Of course, that's why things like the spreadsheet automation, that's why the Jupyter notebooks matter, because you need to automate the mass creation of tickets. You need to automate the mass editing of this stuff. But that's kind of the problem. Like, we got to the point where sometimes we even created a ticket for each meeting item, right? It's like a meeting ticket item that is made of captions and tags, etc., so we can actually track that thing, right? But remember what's the alternative, right? The alternative is to have some Word documents or some spreadsheets, right? Or not being very, well organized. And actually, the thing I used to kind of hate is when I would see a risk description, right, or a description, and on the same paragraph, you had a vulnerability, a risk, a couple of facts that are now completely invalidated, some wishful thinking, some stuff that you go, what is that doing here, right? And basically all of those, or maybe who's going to do it, and all of that in just one paragraph, right? In my head, all of those should be links. We have these vulnerabilities, link, cause this risk, link, maybe cause that side effect, link, breaks that policy, link, right? But now you can track stuff back, right? And remember, what's the alternative? The alternative is having highly inefficient risk functions, highly inefficient functions that are spending their day managing spreadsheets, right? Cool. Now, so what we do is you connect facts with risks. So every one of these yellow boxes is a Jira ticket. So you can say that, we can say this risk story affects this IT asset, is connected to it, has these facts associated with it, has these risk teams connected to it, and these vulnerabilities. And that's where it gets important. You say, hey, you actually need this level of sophistication to exploit, available to these threat actors. Who can cause this impact? So in security, right, we kind of, and I used to be this. I used to be the one going, hey, look, you got this vulnerability. You should fix it, right? And I kind of always sort of, like you say, why am I being ignored, right? Why don't I have a seat at the table? Why I don't have the context, right? It's because, right, a vulnerability by itself doesn't mean anything. You have to put context, right? You might say, oh my God, I got the password for the server, right? I got the root pass for the server. That's okay, right? Is that a problem? Well, it might not be, right? If it's on a container, if it doesn't have any data that you care about, if the attacker can reach it, right, then, I would argue you have bigger problems if the attacker can connect your servers from the outside, right? That's probably a bigger risk than that, right? The other one I like is the SQL injection. You have to fix the SQL injection. You go, really? Maybe not, right? I've seen SQL injection as features, right? Basically, that might be okay, right? Where it runs, what data it has, what's the side effect. More importantly, can you detect it? Right, so these days, I will open a bigger vulnerability and a bigger risk if I can't detect a particular vulnerability than the vulnerability itself. I'm more worried about how I found out about that vulnerability and my ability to understand the side effects of that vulnerability than whatever that thing is. And remember that the big ones are always easy, right? Like the ones where it's like, a massive vulnerability, a massive kind of thing, that's always easy. Everybody will always fix that. It's everything else that's always the problem. So you need to have context, right? You need to make sure that when you talk about a vulnerability, you have to have a path all the way to the top level risk that person cares about. And you have to have a path all the way to the IT system so you can find the system owners. And you have to have a path all the way to the CEO because, again, that's the person making the decision, right? And you have to have a path all the way to the threat actors. And the threat actors, again, we sometimes have this science fiction. Yes, this thing is possible for that threat actor, they can do this stuff. Yes, but is that threat actor actually attacking you? Right? Is that actually part of your threat model? So one of the facts that we have, is basically say, hey, we haven't been attacked by this type of criminal, right? We haven't seen this type of attack, and that's a fact. Now, is that because you don't know about it, right? Or because you haven't? So financial fraud is an interesting example, right? If you don't have a supplier knocking on your door saying, hey, where's my money? And you go to your financial system and says, well, we paid you, right? And then something bad's going on, it means you don't have financial fraud because there's enough built-in kind of alert systems, right? The people that are not being paid is going to complain that they haven't been paid, right? So, you can have a fact that says, hey, I don't have this problem today. Now, it could be because you're crazy insecure, right? But it might mean that your threat actors or there's other mitigating controls in your path that does that. So, here's a bigger example. This is how we to map the projects. You have the projects, we map the threat actors that we're going to address, we mount the outcomes, we basically define what we want to do, and then we map the capabilities. This is how you start to answer the two questions that matter in the business, is what am I doing to you and what I'm not doing to you. In fact, the more I do this, the more I realize that telling the company what you're not doing for them is very important. Because the problem lies if you don't do that, they assume that you are. Right? And then when stuff happens, you go, whoa, what's going on? So it's very important that you start to make the stakeholders understand that, hey, you're number 23 on the queue, right? If you don't like that, talk to the number 10 or talk to the number 12 or give me more budget, right? Because that's the reality, right? Or let's throw more resources into this, right? So that's the thing. This is, I would say, a threat model, and this actually was created by Maeve, right? Which is here, right? And, right, it's obfuscated because, some of the data was a little bit internal, but the thing about this which is very interesting is this was the first time that I saw a threat model that scales. Right? Up until now, I never, the problem I had when I did talk about application security and I talk about the code and you need to visualize everything, is I didn't have a good solution, right? Because my punchline would be, hey, everything's a graph, and they go, ooh, how the hell do we manage this, right? And there was no way, right? Or actually, all the static analysis engines had a graph for this thing, right? Where now, I can now see the connection all the way. So what you have is a threat model that you start by identifying the paths, you start by defining the flows, you start by mapping. So each of those Jira tickets, for example, here, they actually represent an IT system. They actually represent the flow of the application itself. So we start to put our threat model already in Jira, right? And then we actually got a dot environment there. Then you ask the questions, you map the stuff. So again, every single question that happens during a threat modeling session, you capture it. So you can follow it up, right? So more importantly, so you can create playbooks. So next time, you don't start from scratch, right? And that's very important. So now we're doing data science, right? So you can see that there's a path that shows all the way to CEO, there's a thing where you go where the asset goes. So actually, some of these tables down here is very interesting. So for example, this table is actually a table that at the moment is impossible to create in both Jira and Confluence, right? Because a table that shows the parent-child relationship. So what happens is you have a person that is managed by a role, and that managed by a role, we want to view all of that in a table. So we want to say, hey, for this person, who is the first line manager, or the second line manager, or the third line manager? And that's hard because it's based relationships. You have to walk the graph, right? So then you create risk workflows, which is what we have here. The key part here is the risk acceptance bit, right? Because maybe you have to make people accountable. Then we kind of hyperlink the risks. So you can see the R1, R2s, R3s, R4s. And then you can create the dashboards, which I was showing before. And the interesting thing about this dashboard is that you can say, so at the top, you can have your R1s, and then your R2s. So this is something that every project should do. Every project should understand, how is that project going to affect my top line of risk in the business? In fact, ironically, security products sometimes have a negative risk increase. Because they might say, I'm helping you here, but sometimes they might have so many vulnerabilities, or they might require so many risk actions, where actually that you can actually argue that you create a single point of failure. In fact, most security professionals are single point of failure, right? You're one of the most valuable assets to have, right? Because you have a lot of assets. And the name of the game is the other way around. Like, you don't want to have assets. In fact, I would argue we never should touch production, right? We should never be able to have access to anywhere there, because we should be looking, visualizing, understanding, but we shouldn't actually have that power, including key devs or key people, right? That should be always kind of managed in a safe and controlled way. So then you can do deltas, which is cool. If you want to get to the next level, one of the guys who talked about this is Phil Higgins. And the thing is, when you actually start to do statistical analysis, you actually use Monte Carlo sequences to map risk. So I haven't fully got there, but it's really cool, right? And this is where you start to actually, when you don't have data, you start to do analysis to say, hey, I think actually this is a problem versus that one, right? The good news is when you track the instance the way we do, right, is basically you have data to say, hey, this is a problem because I'm seeing this. And that's always the thing. If I have 2 or 3 issues to solve, or 100, how do I make a rational decision? I address these 20 versus those 10, right? So that's the thing. So get an idea, this is our schema. Again, this is published. This is just a small subset of our schema, right? Then you have there, just quickly, you got the project. In this case, the project, delivers a key result, delivers an objective. The project actually delivers a program, part to a business entity, and then that goes all the way down to the company. Then you have, for example, a project requires a role. The role is managed by that person, and that actually belongs to a person. So you can see that I know that this person is going to do that project, do that part with that program, and that's how you connect the dots. Who maybe has these vulnerabilities. In fact, a very important question, especially in security, is to ask, what vulnerability are you fixing today? Right? And if you're not fixing a vulnerability today, it means you're probably not doing something that matters for the business. But it's very easy for us to do all sorts of stuff. But you should always ask the questions, what is the vulnerability that you're actually fixing to now? So we can create tons of workflows. This is why you want to have Jira admins in your team. It's why you actually need to hire lots of people to help you with Jira, because Jira is a tool, right? It's like Slack, right? Same thing. You actually have people that know how to use it. You have to have people that actually maintain it, curate it. So in my team, I have 4 Jira admins, right? We will literally be in a meeting, right? Somebody says, well, I kind of need a workflow. The workflow will be done, right? Before he goes there. Now the thing about graphs, right? I actually realized that there's actually 4 stages of brief on this thing, right? So the first one is, you look at it going, I don't get it, right? It's really complicated. It's a mess. It's really kind of, I'm productive here, right? It's that thing where, well, I can do it like this, and I can do it like that, and I can do it like this. And that's fine, because that person is very productive there. Then stage 2 is when they see something in a graph, they're going, ooh, that's interesting, right? Okay, I cannot do that in 10 seconds, or I cannot do that in a minute, or that will take me a freaking hour to do, right? So but they still argue that everybody else makes a massive mess, right? They go, but why is there all these tickets? Why all this stuff? Why all these issue types, right? Stage 3 is when they really get into it. Right? They get into it, they create tons of tickets, they create new issue types. What they're doing is they're rationalizing their thinking, how they behave, into the tickets. Right? And what that allows them to do is really understand the connections, which basically means they go to stage 4, where probably 70% of what they created was actually redundant. But that's okay, right? Because I did that, right? That's the learning, right? Probably I got to the point where only 5% of the stuff I created is actually useful, right? But you have to go to that part. You have to experiment. The power of a graph is it allows that to happen. It's cheap. It's cheap to add new nodes. It's cheap to let organic flows actually happen. Because the biggest mistake I think a lot of people do with data is they try to control data at the gate. You try to make good quality, good reviews, all that jazz. It doesn't work like that. You create feedback loops. And the feedback loops is what gives you good data, right? That's the fundamental part, right? So yeah, so you got lots of issue types and stuff. So actually, this was a presentation where I talked about 4 important scenarios, so I should quickly do it. This is good. So I basically told the board, I'm not here to prevent incidents, I'm here to prevent crisis, right? The point is, that's why I have a really good incident response team, that's why you're prepared. In fact, a lot of regulation today, the main thing is to be prepared, right? So have a plan to actually act very quickly. The second one is, I'm not here to make you secure, I'm here to make you safe. Right, which is very important, right? If you think about it, insecurities everywhere. Security means that if there's a security control, sometimes you don't want that, right? Or sometimes you have to put it into balance. What matters is safe. Safe for the business, right? For whatever risk decision the business wants to, right? And then what I think I failed at the moment is that I haven't fully connected with risk dashboards, right? So I don't think I've achieved that. And also what I failed is I think making the business case, I've made this several times, I'm yet to really succeed, right? Because I think most people miss a trick with legacy applications, which first of all should be called heritage, or I'm making the money, not you, right? I actually work, right? Not you, right? Because that's what happens, right? This crowd comes along, they work application for a bunch of years, there they go, that crowd arrives, they build the application, that crowd arrives, by the time they get there, they barely understand how the thing works, right? Meanwhile, technology has moved on, here comes a new crowd, and going, well, that one sucks because ABC, and they do the same thing, but that crowd comes along. By the time he gets to there, they're just about the same, right? But okay, the better stack, okay, they get some benefits, right? And for example, if you see what happens with the move to the cloud, is in here there was a lot of network engineers that this crowd says, well, we don't need them, right? We can just shift to production. How cool is that? We can build our own infrastructure with code. How cool is that? And then they realize that there's a reason why we have network security engineers. There's a reason why we care about scalability, performance, backups, resiliency, disaster recovery, all those interesting things that actually matters when you actually deal in an enterprise solution, right? It doesn't matter if you're in the cloud, right? You will create, all that stuff, at another level, right? So I still think companies miss a trick, right? And because the logic is most companies think, hey, I got this thing that I don't understand, I kind of really don't like it, but I don't understand how it works, I'm going to build something new here, right? And my hope is Automatic is going to behave like that, right? I'm yet to see that happen in an effective way. I take the view that if this technology is so good, you should put it under the hood, making sure it's 100% compatible with what's there. So that's the thing. So let me show some demos now. All right, actually, any questions so far?
Yes. If you have lines from the policy with references to chapters and subchapters,
yeah.
and I happen to add 2 or 3 chapters to the policy, how do you renumber everything in Jira?
So, okay, so the question is, how do you add stuff, right? So, okay, so if you add stuff to a policy over here, right, how do you see it, right?
Renumber it.
Well, so the interesting thing about this, right, is in a graph, right, you get feedback loops, right? So if you add nodes, right, and they're not linked to anywhere, they don't show anywhere. Right? And remember that we have access controls, right? So you can actually say that, for example, in a Jira policy, if you make a change, that goes to a state to review.
Yes, but if you put chapter numbers... So if in Jira you have something like 3.2.1.2, do not allow default passwords, and then the policy changes so that that thing becomes 4.5.7.2, how do you update the number in Jira?
Well, so the logic here is that Jira should now be your source of truth for the policy.
So it should be the other way around.
So it should be the other way around.
So update the Jira ticket.
So update Jira ticket and update the policy, right? And the thing about this is people want policy. Like people want a spreadsheet. I don't mind. Like I said, do you want a policy? Do you want a PDF? Cool, I'll give you one.
I was just
I know, yeah, absolutely. But that's the power. But guess what happens today? People do that, right? And nothing happens. Right? People go and say change the policy, and there's no understanding of the side effects of changing that policy. So I would argue that today's status quo is even more dangerous. Because the status quo today is you make change on policies, you don't understand the side effects, and you don't understand if this policy is even correct. Right? Does it make sense? Like, if you have a policy that 30% or 40% of your user base doesn't comply, I don't think the problem is with the policy, right? In fact, I think your policy says we allow that bad behavior. Right? Because that's the norm. All right, cool. So let me now show you behind the scenes, right? Because I think it's interesting to see this, right? So all of these runs on open source, right? And it's basically what I call the OSBost. So can you guys see this? Is that too small? Or is that kind of okay? Oops, sorry. All right, so I'll put it like this. So actually, first of all, you want to see it in action, right? Okay, let me just see it in action. Cool. So here's the JS bot in action, right? So you can go, so at the moment, I've wired on Open Security Summit, right? So that's the bot there. You can see, you come and say hello, right? You come and you can say, hey, what you got, right? So I start to have an interactive view of it, right? So one of the things I can do is I can issue commands, right? So I can say, hey, give me a screenshot. By the way, if anybody here from Slack, I know people from Slack, right? And the thing is, Slack wants to compete with, G Teams, whatever that thing's called, right? Slack removed the best feature they had, right? And the best feature they had was this little thing that allowed you to go up, right, on the thing and get the previous command, right? Which basically made this a really great CLI, right? They took that feature away, which for me is a good example. They don't have good metrics because they probably don't see people using that stuff, right? And that was one of the single biggest features that Slack has. Because to me in CLI, you need the interactivity. You can't be freaking, like you're gonna see my pain now, right? My pain now is that I'm actually gonna have to freaking, copy and paste the things when I want to show more examples. And what it means you lose your mojo. So the thing about when you interact like this is that if you have a workflow where you have a jump of 10, 20, 30 seconds, that 10, 20, 30 seconds costs you 10x. Right? That's why when somebody disrupts you, from your context, you lose your mental models. Right? So I'm very big about reducing everything to seconds and milliseconds, because it's when you get to that speed that you actually have a mojo. You actually have a flow. You're flowing in your thinking. You're actually not affected by the thing. So cool. So I can come in here, right, and I can go, for example, and I can say, let me, actually OWASP, right? Let me get a screenshot of OWASP, right? So what's powerful about this is what's happening out behind the scenes is that, is that correct? Oh, it's org, isn't it? All right, there you go. See the point? See the point? Right? See, I just lost valuable 20 seconds, right? Because I had to go up, copy paste that in. Yeah, see? Again, Because by the time I copied, I forgot what I was about to do, right? But it makes a difference, right? Like, this is the thing, like, you might look at this, right, and thinking, well, that's nitpicking. But it's the incremental fixing of this nitpicking that makes you productive. It's the same thing as incremental benefits, like the guys on the cycling team in the UK, right? You have to be fixing this all the time. Because if you don't do this, right, you don't get to that point where you're really flowing, right? All right, so cool. What happened here is I basically took a screenshot, right, of OWASP website, right, which is already quite interesting because actually, even today, there isn't an interesting solution, right, to just take full screenshots of websites, right? So, the way this works, and this is kind of important, right, this happened through a serverless workflow, right? So let me kind of walk you through what happens here, right? So what happens here is basically, when I go hello, I go screenshot, that is calling a Lambda function, which is a serverless function that just exists on AWS for a couple of milliseconds, right? So let me walk you through the codes so you get to see it. So there's this project called OSBost, right? And in OSBost, that's too slow, that's too small probably, right? Or is that good? Can you guys see the code here? Yeah? All right, cool, all right, great. All right, so this is, that at the top is the first Lambda function that you hit, right? So that's the entry. So that's the Lambda function that is now running that gets called by the handler, right? So it's triggered by, and this is basically an API gateway that calls this Lambda function. So Slack sends an event, API gateway triggers a Lambda function, calls that guy, right? So, and that's basically the vanilla kind of thing that happens, right? So when you go in here, then if I go into there, you got a bigger router where this is kind of the code that Slack asks you to do. So I'm kind of going to move a little more. So that basically says, yes, if an ID, if I get it, I'm going to call this process event. Then this determines if it's a message, if it's an app mention, if it's a response, calls handle command, which is here. And then handle command, so this I did a trick here because I go, well, can resolve the command name and ends up here, right? Okay, so this is the good bit, right? So, oops. So this is basically a method that each function is a command in the bot, right? So when I go help, right? So if I go to the bot and I say, you know, help, this is basically now issue another, so if I issue one of those commands, right? To go and give me a list of every one of those functions that is there. So that means that you can see, right? See here, browser dev FAQ hello help. There it is, browser dev FAQ somewhere, JP, Jupyter, etc. Help, etc. Help. There you go, right? Sorry?
Like CLI.
Yeah. So that's it, right? So that's just CLI, right? So, and this, again, in code, this matters, right? It matters that when I want to add a new method, I just come in here, right? I want to add a new functionality, I just come in here, right? It's pretty straightforward. In fact, what you'll see is most of these actually call another Lambda function. So for example, in this case, you can see that the Jupyter actually calls that Lambda function and invokes it synchronously. The browser does the same thing. The screenshot, there you go, right? So you can see. So the screenshot function, which is here, is saying, hey, can you call that Lambda function with the parameters that you just received from here? And then that base shut down. So now we have a second Lambda function, called asynchronously, that is going to handle the screenshots. Yep?
So, 2 points. You don't have control over the input.
Sorry?
2 points.
Yeah.
You don't have the control of the input.
Control of the input, right?
So the question is, A, I don't have a control of the input, right?
Yeah, because you can find an injection. It's pointing to a serverless. There is no runtime control at all. And
So in this case, right? So this is very, so first of all, like, I would argue, if any guys are a developer, right? Do a lot of code review, do application code review, because it makes you a really good developer, right? So I would argue that the concept that I have of what's possible in code is very different from most developers, right? Because from security, we'll teach you that there's always a way. It just depends how crazy it is that you do it, right? But sometimes the crazy way is better than when you play fair with the framework, because the framework makes you sometimes do even crazier or insecure ways, right? So in this case, from a security point of view, I'm delegating, right, the validation of this to the Lambda function.
without runtime control.
What do you mean without runtime? No, I'm just passing the data that I'm getting from Slack all the way to a Lambda function. So the first Lambda function passes to the second one.
So you don't have nothing controlling the runtime.
What do you mean the runtime?
I mean, do you have a twist lock or something blocking any injection?
Well, so this is the interesting part, right? So this is running, okay, so the question is, do I have anything to block the malicious things in there, right? Okay, so the reality is I would actually argue, right? As a developer, and even as a security professional, I don't have that problem, right? Because this is running on a container, right? On a disposable environment, right? So even if you popped in there, you wouldn't get a lot, right? And then it's running on Python, right? So basically, if you pop in here, you just found a 0-day on Python, right? So you pop this and you pop anything else. But this is a good example, like, in a way, like, if you didn't monitor this, if those kind of things start to happen, actually, AWS would just give me more Lambda functions, right? But there might be a path, but I would argue that, look, I'm passing down the responsibility to somebody downstream to do this. So what it means that my first gateway is always clean. So my principle with this is I never want this one to crash. And the reason why is because when this crashes, you feel very lonely, right? Because your bot doesn't work, right? So the worst one is when the bot itself doesn't work. And I always think that it's about design, like on OS. Why the hell a process can crash the whole OS, right? Like, or block the OS. The OS should say, no, I'm giving you X percentage of CPU. If you max that out, your problem, right? So I would argue here, I never want this my first routing function to crash. So I just literally pass on to the next one, making sure that this always works. Okay, so now we go to the second Lambda function, which is the one that does the browser stuff, right? So now what you get here into the Lambda, which is called, so I can see my Lambda function, you can see OSBost browser. So this is actually a separate project called OSBost browser. And then here, I can go to my Lambda functions, and I can see I should see my screenshot, which is here. So you can see Lambda functions, and actually this here, right, see that OS browser, Lambda browser, is actually OSBost, Lambda browser, right? So this is now the code, right, that is actually going to run when that particular function gets called.
So it's literally like 12 lines of code, right? Setting that sort of code.
Yeah, so what this calls, okay, same thing, right? So what it's actually doing, in fact, you can actually see here that I actually pass a parameter called screenshot. So I'm actually reusing a function. So that is actually a helper function, actually, because what actually happens, if I go here, I can go browser. So if you go to browser, and you can see, hey, the browser actually has a screenshot command. Right? So I'm actually using the browser command, and I actually create almost a shortcut for the browser command, which calls on that particular function. So in this case, when I go into my Lambda browser, again, if I follow the commands here, so I can go into my command helper, which is here, right? And then actually this guy actually has, here you go, browser commands. So there is the same thing. Look, see, there's the Slack. This is a really cool method, by the way. This actually takes screenshots of Slack itself, which is something you can't at the moment, but you can here. So if you want to take a screenshot of a Slack channel and you want to control the history, you can do it here, right? There's my screenshot, right? So my screenshot is basically this code here, right? Now this code is really interesting, right? So this is the kind of code that will really help you a lot because, this is the kind of stuff that I had to solve this, right? So this was probably this was actually the first method that I really solved, right? Because what's happening on that screenshot, right? And let me maybe show the screenshot a little bit faster, because that delay, and you see the problem? How annoying it is? Right? I have to go here again, type screenshot. Yeah. Right? And I have to go HTTPS, Google, because that tends to be quick. Right?
Nope.
See, Slack, if you're looking, right? Please add that feature back, right? All right, so if I do this, right? So this takes a screenshot, and what happened there? There you go. Okay. Yeah. So it takes about 3 seconds, right? 4 seconds, right? So, and by the way, 1.5 seconds is actually Slack, right? So in that period that it started, right? What actually happened behind the scenes is the Lambda function started, right? Chrome headless started. I opened up G Suite, Google, I took a screenshot, and then sent it back to Slack. And that's within those 3 seconds. Right? So that's the power. And then that Chrome instance it's actually gone, right? So I don't care about it anymore. Right? So that's the power of this thing. And then what you see in that code example is basically the code that does that, right? So the code that starts the serverless, does the thing, gets the screenshot. So the patterns here tend to be very, right? So basically, I open up the browser, right? And then I get the screenshot, and I send the data to Slack. Each of these are now individual Lambda function methods, right? So the power is so what I've done here is I commoditized the power of doing a screenshot. Now you might think, why does this matter, right? It's because suddenly you can do very interesting things like this. So this is actually not this schedule. So one of the things that we did, for example, and code complete would be really good. Another good feature if they really want this to be a CLI, right? All right. So this is for the summit, but you can see that one of the things that we have here is this screenshot. Now, this screenshot is going to show a feature that for me was very powerful. Again, you see, you give a nice little message to the user, fetch the latest version. So this screenshot, right, is actually different from what happens if I browse that page. Right, so that is actually browsing a particular page in the Open Security Summit, but if I go in there, or for example, that's Friday, right? So if I go to the Open Security Summit, what you get on Friday, the thing, is basically something a little bit different, right? You see there's this guy here, there's the edits, there's the schedule by day, that guy's there, there's these bits here, right? If you compare that with this is much cleaner, right? And it's the attention detail that matters, right? See how that thing is a bit smaller? It makes a difference, right? It makes a difference when I'm consuming that. Let's go here. Now, the way this was done is because I can run a little bit of JavaScript before I take the screenshot. So the workflow is basically, you open the page in Chrome headless, and you take a screenshot, so you open the page, you run a bit of JavaScript, which is basically jQuery, or you inject jQuery if you need to, right? And then jQuery, you allow it to clean the CSS and take a screenshot out. So if you, for example, see the Jira that we actually have internally, the screenshot of Jira is way more consumable. It's way better than the one that Jira gives you on a page, because you take away the stuff that doesn't matter. But also, for example, in the Jira example, we actually log in. So actually to take a screenshot of Jira, you actually have to go there, log in, make a couple of change settings, go to a particular page, take the screenshot, actually fix it, take the screenshot, come back. But once that takes 3 or 4 seconds, you don't care about that workflow, right? So what you have here is that, so for me, like anything you can do on a website, right, I can take a screenshot. I even did once where you log into Elastic and you took a screenshot of a particular part of the screen that was actually showing a particular kind of dashboard, right? Because you got that thing. Now what you want to do, for example, in this case, you want an environment where you can run that locally. So the way I developed this is that you want this environment where you can run your functions locally. So let me show you a good example of this. Right? So what you have here is a Lambda function. Right? So if you see at the top here, right? So I have a Lambda function that says, hey, this will be a Slack message. Right? So this is the most simple Lambda function you can have. Right? It's just a Lambda function is going to return a value. Right? What I have here at the bottom is I'm going to call a deploy function and I'm going to run it. Now who has written a Lambda function here before? Alright? So if I ask you to do this, and run the Lambda function in AWS, how long will it take you?
To deploy it?
Deploy it, run it, get the feedback loop, see the output of the Lambda function.
With CI/CD, 30 seconds or something?
Cool. Yeah, about that. Probably do cloud formation and push some stuff across.
Yeah.
Cool. Anybody has similar kind of thing? Sorry?
Long time.
All right. The problem with that is wrong by an order of magnitude, right? Like anything above 3 seconds, you lose your mojo, right? You lose a chain of time. So imagine, think about it. If every time you want to make a code change takes 30 seconds, that means that you think, I'm going to do something, I make a change, I upload it, I'm going to get coffee, right? Oh, cool, I'm going to do this, oh, it didn't work, go back. So you don't have the loop, right? You're not effective. And also, that's why people then try to run it locally. So you have, it's amazing, you have this entire now system designed to deal with the fact that you can't run it dynamically. So the cool thing when you think of security is you go and you hunt, like, why does it take this time? Why does this, that? So in this case, deploying a Lambda function is simply copying a file to S3, right? Telling AWS that the Lambda function has been updated and calling it, right? So the reality is that it shouldn't take that long, right? And the bottom line is that it doesn't, right? So if I go like this, right? That was it, right? So okay, let me actually run this automatically so you can actually see it, right? So I flick a little switch here in IntelliJ. That means that every time I make a code change, my test will run, right? Okay, so let's see this. So you can see that I'm going to go here and I'm going to say, hey, I'll leave my hands, test runs. If you look here, there's my change. So that Lambda function has been deployed to production, right, or QA in this case. Like production will have a different pipeline, right? And that's the loop that you want, right? If you don't have that loop, right, it means you have inefficiencies. And then ask the question, why do you have that? Okay. So by the way, so this is actually open source. So what I've done here was I create a wrapper around Bottle3 because again, Bottle3 is too complex. So when I look at API, I would say, I want to do X. So if I want to deploy a Lambda function, I should just go to write update, or deploy, or create, or invoke, right? That's it, right? So it shouldn't be there. So since I'm running a bit out of time, let me show you the other really cool feature with the Jupyter notebooks, right? So what you have here, and you can type Jupyter, right? But that was always very hard to type, right? So I kind of type JP. So what you have here now is Jupyter notebooks on demand, right? So I can come in here and I can say, hey, which servers do you have running? Right? Again, it's servers, not server, right? And then, because I don't have one, I'm going to go JP start, right? So what this is this is now starting Jupyter notebooks as a serverless function, right? So what's interesting behind this is what's actually happening here is I'm actually running this off code build. So if you go to AWS and you go to code build, what I'm going to see here is basically a build that just started. See that build? So that build just started and is being provisioning, right? So basically, Google is actually provisioning, AWS actually provisioned this. And actually, if you pick the highest one, that takes 7 seconds. So if you, ironically, so if you pick this, the cheaper, kind of lower kind of image environment, it takes about 50 seconds. But this is very interesting, right? Because what's happening here is that I try to use Fargate, which is Kubernetes. I try to use the containers. It all felt too complicated, right? It's like I said, I just want to start a freaking Docker, right? Like how complicated could it be, right? I got a Docker image. I want to put some commands, just run the thing, right? So when I look at code build, because I was doing the code build for the automation of the OSBost stuff, I got it really well. I could actually create a whole code build pipeline programmatically. And I go, wow, this is really cool, right? Because code build actually has a lot more options, but also give you really cool logs, right? So what you have here is all the logs, right, for what's going on, right? So this is actually the logs for the image. So what I do here is I go, hey, can I run this? Actually run a couple of little things just to make sure they're the latest, and then start, what's it called? Start Jupyter, right? And then what's interesting is that now you have Jupyter running, right, inside my channel, and then it gives you a little password there, right? So the challenge was, okay, how do I access the Jira, the Jupyter running inside my code build, which is running inside my build? And this is where, you know, the security team going, that's really cool, because that's really secure, right? All you have to do is fire up ngrok, right, or a proxy, and you get the stuff up, right? So again, you know, from a security point of view, you know, or for the old school between you always can do ncat, right? Or if you really want to go cool, you could just obfuscate it through HTTP to your own proxy server on the internet. I didn't need to go that far, but I started ngrok, so that means that all I have to do is parse it, and I get a link, right? So now I get a link into here, so I can log in to my Jupyter notebook, and then basically means I can access my notebook directly from there. But this is why all these little things matter. This was very interesting, but if you can now persist this data, it's pointless, right? So if you cannot fix this data in a way that you don't care about it, right, people won't use it, right? Because you make some changes, but then how do you save it? And I'm going to find in the crowd that has Jupyter a solution as clean as this, because there's always this maintenance stuff, all these kind of things, and I would argue, I don't need that at this moment in time. What I want is actually something where I can come in here, I can edit, right? So this is a new cell in OWASP, right? Wait. And so I can run it, and I can actually, again, do that the answer is always 42. right? So there you go, 42. So now, what I want is to persist this, right? So if I now go to GitHub, right, and I go to the repo that thing came from, what I'll see is a commit just made just now with that change. See there, 30 seconds ago? There's the change I just made, there. So now you have a workflow where this became serverless in a way, because I don't care, right? I start basically a Jupyter notebook is autosave. I tell it to kill itself in half an hour, 1 hour, or 2 hours, whatever, right? And then should I need one, just start it, and that's it, right? So from my point of view, I can now make changes in this Jupyter notebook in a way that I don't care about the process that takes it to start it. So this is a good example of the kind of workflows that you do. And there's actually, when you actually go here, oops, there's actually a lot of other interesting stuff that you can do, because you can actually take screenshots, right, of the Jupyter notebook, right? And in fact, we actually have a version that you can actually execute the Jupyter notebook itself, which is really cool, right? Because what it means that your Jupyter notebook now becomes your report. In fact, that thing I showed you from Maeve was created like this. Right? So it's actually Maeve creating a Jupyter notebook that tells the story that she wants, going to the bot and say, hey, give me a screenshot of that particular notebook, which now is in Slack, that you can copy and paste, share around, and go. So there you go. So there's a lot of other really cool features. Sam is saying I got out of time. So final thing, right? If you want to do this, the main repo is this guy here. The Open Security Summit has a good example, so you might want to start there, and then it's all on OWASP OSBost, right? And again, if you can help me with this kind of stuff, I don't have a lot of time at the moment. So the bit that really could do a bit of work is just that initial onboarding, right? And maybe make it work on Google Cloud and Azure and all that stuff, we have a ServiceNow and all those jazz. So thank you. And thank you very much.